All right, guys. Hello. Welcome to another one. This one is Quiz 9, Implicit Differentiation. And let's get right to it. All right, so here we go. The first ones, guys, are pretty simple. This one just wants a derivative. It's not anything crazy. You just go right into it. F prime of x is equal to, bring the 3 down, x squared minus 4 raised to the power 2, because you subtract 1 from that power, times root of the inside, so 2x. So then that becomes 6x, x squared minus 4 to the second power. And we look for that, and there it is. All right, let's go to the next one. It is the same thing, guys. Calculate the derivative. We got to do product rule. So f prime of x is equal to first times root of the second. The derivative of cotangent is, the derivative of tan is secant squared. The derivative of cotangent is negative cosecant squared. So negative cosecant squared of x plus second cotangent x times the root of the first. 8 times 2 is 16, so 16x. So let's rewrite this. So let's see, a negative 8x squared cosecant squared x plus 16x cotangent x. And we'll look for that. Next one, guys. All right, so determine the values of x for which the derivative is 0, given that the derivative is this value. So let's take the derivative. So the derivative is 2 negative x squared plus 9 raised to the power 1 times the negative 2x. So let's rewrite this. So it's going to be a negative 4x, negative x squared plus 9. And this is what I'm going to set equal to 0, guys. So I'm going to set that equal to 0. So let's see. First thing I notice, I can have a 0 on the outside. If x equals 0 on the outside, the whole thing will be 0. Because negative 4 times 0 is 0, and 0 times anything is 0. And then I look at this inside expression, negative x squared plus 9 equals 0. If I want to move the negative x squared to the right, you have 9 equals x squared, and then square root, you get plus minus 3 equals x. So the answers are 0, negative 3, and positive 3. All right, let's continue, guys. Determine the value of x for which f prime of x is greater than 0. So this means where f prime of x is positive. So here gives me the function. So again, I'm going to do the same thing. Take a derivative. So when we take the derivative, you can have 2 parentheses negative 9x squared plus 4, close it to the power 1, times the derivative of the inside, negative 18x. So my derivative equation is going to be 18 times 2, I think that's 36. So negative 36x, parenthesis, negative 9x squared plus 4. So what I'm going to do is, I'm going to do something called the railroad tracks, guys, or finding my critical numbers. So I'm going to equal that to 0. So immediately if I equal that to 0, I get 0, because 36 times 0 is 0. And then if I solve for this on the inside, again, just like last time, negative 9x squared plus 4 equals 0. Move the negative 9x squared to the other side. 4 equals 9x squared. Divide by 9, divide by 9. And then you're going to take the square root, and you get 2 over 3 plus minus equals x. So then I do railroad tracks. Here are my railroad tracks. And I'm going to plug in 0 and then positive minus 2/3. So here's 0, negative 2/3, positive 2/3. All you care about is where is it positive and where is it negative. So I'm going to choose a number to the left of negative 2/3, like negative 1. If I plug in a negative 1 in here, so negative 36 times a negative 1, that's positive. And the negative 1 squared is a positive 1. 1 times 9 is or negative 9 is a negative 9. Negative 9 plus 4 is still negative. Positive times a negative is a negative. So I see a negative. A number between 0 and negative 2/3, like maybe like negative 1/4 or something like that, or negative half. So let's see. Let's plug in negative half. Negative 36 times negative half, that's a positive. And then if I plug it in here, let's see, negative half, when I square it, turns to 1/4. 1/4 times negative 9, it's going to be negative 9 over 4, which is a number smaller than 4. When I add 4, it turns to a positive. So positive times a positive, that's a positive. See? All right, let's keep going. My number between 0 and 2/3, if I plug in a half, Negative 36 times the positive half, that's negative. Half squared is 1/4. 1/4 times negative 9 is negative 9 over 4 plus 4, that's a positive. Negative times a positive is a negative. And if I plug in a number bigger than 2/3 like 1, negative 36 times 1 is negative. 1 squared is 1. 1 times negative 9 is negative 9. Negative 9 plus 4 is a negative. Negative times a negative is a positive. So it wants to know where f prime is positive in this interval and in this interval. Notice there's no equal sign, so no brackets. So negative 2/3 to 0 and 2/3 to infinity. Alright guys, I'm a little stuffy, my apologies here. Alright, here we go. It wants dy dx, that's the same thing as saying derivative. So dy, well before I even take a derivative, here we go. Y equals, and I'm going to rewrite this as 5x cubed plus 3 to the half. Now we're ready for a derivative. Dy dx is equal to, bring the half to the front, parenthesis 5x cubed plus 3, close it to the negative half, times the derivative of the inside, which is 15x squared. You're done. Now let's just make it pretty. So I'm going to bring this down. So let's see, 15x squared stays in the top, 2 in the bottom. All this right here has a square root on it when you bring it down. Square root of 5x cubed plus 3. And I think that's it. So there it is. All right, let's continue, guys. All right, so now we're getting somewhere. So here we go. It wants dy dx, and I'm going to have to do this implicitly because I have y's in there. So here we go. The derivative of 2x cubed, that is just, what's that? 2 times 3 is 6. So that's just going to be 6x squared. The derivative of 2y cubed is going to be 6y squared, but that's not an x. So then I got to write dy dx minus, and then you're going to do product rule right there. You can group the 5 with the x if you want, guys. So here we go. First times the derivative of the second, dy dx, plus second times the derivative of the first. All that equals 0. I'm going to distribute it, guys. So here we go. 6x squared plus 6y squared dy dx minus 5x dy dx minus 5y. I distributed the negative like so. Equals 0. Now it turns just to algebra. So all you got to do is algebra, and it's kind of fun. Group the dy dx's on the left. Everything else moves to the right. 6y squared dy dx minus 5x dy dx equals 5y, because I moved that to the right, and I moved this to the right. So 5y minus 6x squared. Factor out our dy dx. So dy dx factored out. 6y squared minus 5x equals 5y minus 6x squared. And then just divide, because it is a product. Dy dx times this guy, 6y squared minus 5x. So divide by 6y squared minus 5x, and you get dy dx equals 5y minus 6x squared over 6y squared minus 5x. And then we just look for it. And there it is. Cool? Cool. All right. Here we go. Let's do another one. Ha, LOL. All right. Dy dx, and I have this expression, 6x minus y raised to the power 2 minus 6y equals 4. Again, we're doing the same thing, guys. We're doing the exact same thing. I'm going to move the 2 to the front. So 2, leave the inside alone. 6x minus y raised to the power 1. We don't have to write it in there. And we're not done yet. Ooh, I almost made a mistake. Times the derivative of the inside. 6 minus dy dx. Close it. Minus, and the derivative of 6y is 6 dy dx, which equals 0. The derivative of 4 is 0. Then make sure that I didn't make any mistakes. 2, leave the inside alone, raised to the power 1, times the derivative of the inside, 6 minus dy. Okay, perfect. Everything's good, guys. So now what we're going to do is I'm going to distribute all of this like that. So let's see. I'm going to distribute, so 2 times 6 is 12, so I'm going to write 12. 6x minus y, close it, minus, and I'm going to write 2 dy dx, 6x minus y, close that again, minus 6 dy dx equals 0. So I'm going to move this guy to the right, because the other twos have a dy dx. And you know what? I'm going to move these in blue to the, well, that's not blue. These in blue to the right, because I want to have positives. I want to have the dy dx be positive. So I'm going to rewrite it on the left-hand side, guys. I hope that doesn't confuse you guys. So here we go. 2 dy dx, 6x minus y, minus 6 dy dx. Oh, no, I moved it to the right, so it's plus. Equals 12, 6x minus y. So now what I'm going to do is I'm going to factor out a dy dx. So here we go. Dy dx. And when I factor that out, I'm going to be left with 2 6x minus y plus 6. So it looks like, well, I'm not going to, or in a little bit, maybe we'll reduce it. We'll see. Equals 12, 6x minus y. All right, now I'm going to divide. So I'm going to have this. Dy dx is equal to 12, 6x minus y over 2 parentheses 6x minus y, close it, plus 6. And at first glance, you're like, Chavez, that isn't in there. Yeah, it is. You just got to reduce it. So notice what I have in blue. 12, 2, and 6. Those three are all even numbers, so I can factor out a 2 from all of them. If I factor out a 2 from all of them, then I have this. I have a 6 parentheses 6x minus y. And on the bottom, I'm going to have 6x minus y plus 3. Now I can just take out the parenthesis in the denominator, and I can distribute this here on the top like that, see? So my final answer, 36x minus 6y over, let's see here, 6x minus y plus 3. All right, and that's it. So now we look for it. 36x minus 6y over negative y plus 6x plus 3. There it is. Yay! I hope you guys are having fun with this. If not, I apologize, but I still hope somewhere deep down inside that you love this and you're like, OMG, this is so much fun. All right, let's go to the next one. So I'm going to take a derivative. So here we go. Recognize the product rule on the right-hand side. Dy dx is what they want. Should I do it in blue? No, let's stick with red. The derivative of sine is cosine. So I'm going to write cosine, leave the inside alone, 5x plus 4y. And then I take the derivative of the inside. The derivative of 5x is 5, and the derivative of 4y is 4 dy dx. And all that equals, I'm going to do product rule first, times derivative of the second, plus second, derivative of the first, which is just 1. And looks like that's it, right? So now we're going to have to do is solve for dy dx. So I'm going to distribute all of this like so. So here we go. I'm going to have 5 cosine 5x plus 4y plus 4 dy dx cosine 5x plus 4y equals x dy dx plus y. So now what you want, you're done. You're just going to do algebra. So I'm going to rewrite everything, all the dy dx's on the left-hand side. So 4 dy dx cosine of 5x plus 4y minus x dy dx equals y minus 5 cosine of 5x plus 4y. So now I'm going to factor out a dy dx. So when you factor out a dy dx, you have 4 cosine 5x plus 4y minus x equals y minus 5 cosine 5x plus 4y. And then finally divide. So we have dy dx equals, let's see, y minus 5 cosine 5x plus 4y over 4 cosine 5x plus 4y, close it, minus x. And we look for that. And here it is right there. Kind of cool, right? Yay, it is kind of cool. I know you love it. I know even if you say you hate it, I know you really love it. All right, here we go. LOL. So let's find this. This wants a second derivative, guys. So first, find the first derivative. So first times derivative of the second, dy dx, plus second times derivative of the first, so it's just 1, plus 2 times 2 is 4, 4y dy dx equals 0. So move everything that does not have a dy dx to the right. So x dy dx plus 4y dy dx equals a negative y. Factor out a dy dx. So here's me factoring dy dx, and we have x plus 4y equals a negative y. And then finally divide. dy dx is equal to a negative y over x plus 4y. All right, that's not the answer. Now we're going to have to take another derivative again. So I think I have enough space down there. If not, let me switch it to blue. So here we go. I'm starting it again, and I'm going to do quotient rule. So my second derivative, bottom, x plus 4y times rid of the top, negative dy dx, minus top, negative y, times rid of the bottom. Let's see, 1 plus 4 dy dx. All this is over bottom squared. X plus 4y, close it squared. So now let's see if we can make it pretty. I'm going to come back down here. Yeah, I should have written it down here. Sorry, guys. Second derivative dx squared equals, let's see, x plus 4y times a negative dy dx minus a negative y times 1 plus 4 dy dx all over x plus 4y squared. Okay, so now what you got to do, guys, is all algebra. So I'm going to replace dy dx with this guy right here. So bam, that goes in there. There we go. And it goes also in there. So yeah, let's do that. I guess, let's see, does anything cancel out? No, let's just go right into it. So here we go. X plus 4y times a negative, which is a positive, so y over x plus 4y. And then negative times a negative is a positive there, so I'm going to write plus y times 1 plus 4, parenthesis, negative y over x plus 4y. And all this is over x plus 4y squared. All right, so let's multiply this. So finally, here's what we get. Let's see. We have xy over x plus 4y plus 4y squared over x plus 4y plus, let's see, it looks like it's just a y, minus 4y squared over x plus 4y. And all this is still over x plus 4y, close it squared. So notice that all of them have an x plus 4y except for the y here. So I'm going to multiply this y there by x plus 4y over x plus 4y. And when you do that, and I know I'm coming into this guy, but you know, hopefully we'll still have some space there. When you do that, here's what we're going to get. xy over x plus 4y plus 4y squared over x plus 4y plus, let's see, y times x is yx plus 4y squared over x plus 4y minus 4y squared over x plus 4y. And all that is over x plus 4y squared. All of them have an x plus 4y, so I'm going to bring the x plus 4y squared up. And here's what we finally get. xy plus 4y squared plus yx. So you can write xy first if you want, but there it is. Yx plus 4y squared minus 4y squared all over x plus 4y times x plus 4y squared. So these cancel out. These here combine. My final answer looks like it is 2xy plus 4y squared over x plus 4y to the third power. So there it is. Sorry guys, I know it wasn't like super awesome, but it's kind of cool because it's kind of like a little game, you know what I mean? So yeah, so now it took up some of that space. And what am I going to do? I guess we'll just leave it there. Okay, so it says compute the second derivative, x squared plus y squared equals 18. All right, so let's just go ahead and take up this space, and then this one will take up the other space. So here we go. I'm doing this one down here. So taking the derivative, 2x plus 2y dy dx equals, the derivative of 18 is 0. Move the 2x to the other side, so 2y dy dx equals a negative 2x. Divide by 2y, so we finally have dy dx equals a negative x over y, because when you divide by 2y's, the 2's cancel out, see? So now we're going to do the second derivative of that. So here we go. So the second derivative is going to equal to bottom times root of the top minus top times root of the bottom all over bottom squared. And they gave me a point. The point was 3, 3. So from there you can just substitute in, guys. The point was 3, 3 for both. So I'm just going to substitute 3 times a negative 1 minus a negative 3. And let's see what dy dx is. Right here, dy dx at 3 comma 3 is equal to negative 3 over 3, which is just negative 1. So negative 1 over 3 squared. So you get negative 3, let's see, minus, it looks like another 3 over 9, so negative 6 over 9, so that's a negative 2/3. So we come back, and there it is, negative 2/3. All right, guys, let's keep going. So number 11, I'm going to do number 11 down here. Find the equation of the tangent line to the curve at this point, 3, negative 3, given that x squared plus xy plus 2y squared equals 18. All right, so let's do that. Let's see how much we can do right here. So 2x plus, so product rule, first times root of the second, plus second times root of the first, the derivative of x is just 1, plus the derivative of 2y squared is 4y dy dx equals 0. So I already have a point. All I need is dy dx, guys. So I'm going to move everything else to the right. So here we go. I'm going to rewrite this as x dy dx plus 4 dy dx equals, 4y. Thank you guys for letting me know. LOL. Equals negative 2x minus y. So now I'm going to factor out a dy dx. I'm going to write it up here. Dy dx. And then if I factor that out, I'm going to have x plus 4y equals a negative 2x minus y. Hopefully I didn't make any mistakes. Divide, divide. So my final answer, dy dx equals negative 2x minus y over x plus 4y. I don't think they want, they wanted a tangent line. So I just need my slope. So dy dx at 3, negative 3 is equal to, negative 2 times 3 plus 3, because minus a negative turns into a positive, all over 3 plus 4 times negative 3. So let's see what we got here. Negative 6 plus 3 over 3 minus 12. So negative 3 over negative 9. Did I do that right? So 1/3. So my slope is 1/3. So my tangent line is going to be y minus a negative 3, so y plus 3, equals 1/3 x minus 3. And they're not going to have it like that, guys. You're going to have to simplify. So y plus 3 equals 1/3 x minus 1, minus 3, minus 3. So my final answer is 1/3 x minus 4. So there you go. All right, let's do question 12. I believe this is the last one. Yeah, we got plenty of space down there. It says find the derivative of this function, and it looks like we have a quotient. So let's go right into it. So I'm going to use blue, guys, to differentiate from this top half right here. So I'm going to write bottom. So bottom is square root of x squared plus 2 times root of the top, 3, minus top, 3x times root of the bottom. Now I know that the bottom is x squared plus 2 to the half. So I'm going to take the derivative of that. So 1/2 x squared plus 2 to the negative half times 2x. And so did I do this right? Bottom times over the top minus top times over the bottom, all over bottom squared. When I square the square root, you're going to have x squared plus 2. All right, so now let's simplify and see what we got here. So we have 3 square root of x squared plus 2 minus, let's see, these 2's cancel out, the 2 cancels out with the half. So I have a 3x on the top, and on the bottom it looks like I'm going to have the square root of x squared plus 2, and all this is still over x squared plus 2. I recognize and I look that all of them have x squared plus 2, but either raised to the 3/2 or a square root. I don't have a square root, so I bet you what they did is they found a common denominator. This is over 1. Multiply this guy, let's see, that's already a square root. So let's multiply by the square root of x squared plus 2 over the square root of x squared plus 2. So when you do that, here's what you're going to get. 3, and then square root times square root is just going to be x squared plus 2. Excuse me. All over the square root of x squared plus 2. And then minus, and I still have 3x over the square root of x squared plus 2. And all this is over x squared plus 2. So I'm going to keep it now. So here's what I'm going to have. 3x squared plus 2 minus 3x all over the square root of x squared plus 2 times x squared plus 2. Now remember from your algebra day, guys, side notes, guys, x, the square root of x times x is the same thing as saying x to the half times the whole x. So on whole x is x to the power 1, and 1 plus a half is 3/2. So I can rewrite this as, and look, I'm going to go ahead and distribute as well. 3x squared plus 6 minus 3x all over x squared plus 2 to the 3/2. So there it is. I look for that answer. And, oh, okay. You got to do a substitution. Let's see. Hold on, guys. Oops. All right. It looks like this guy should have been a 3x squared. Did I forget it somewhere? Let's see. There you are. Bottom times rid of the top minus top. And top was 3x. Nope. Oh, yeah. Right here. So look. Sorry, guys. That is correct. But look. What is x times x? So that should have been a 3x squared. So sorry for that error. Relax. It's not the end of the world. All right. So now the 3x squares cancel out. And we have 6 over x squared plus 2 to the 3/2. So my bad, guys. Hopefully that was kind of fun for you. Maybe you caught the error immediately. So sorry about that. But there it is. It's now fixed. And the correct answer is letter D. All right. I hope you guys had fun with this one. Hopefully give it a thumbs up, guys. I would appreciate it. If not, well, I guess that's okay. And I'll see you guys in class on Tuesday. All right. Later, guys. Bye.